Hi, everyone. My name is Alex Reynolds. I'm the CEO of ATTX, and today we're going to be talking about what ModelSpace is and why even use it. Why does ModelSpace even exist? What is the value that it brings, and how can it be useful to your team or your organization? So ModelSpace is really a lot of tools in one. And really what I'll come to describe in this presentation is how ModelSpace takes essentially everything you need to do to develop a software project or a really good space project through end to end and build it into a single framework, and a lot of the value that comes from that sort of an approach. And really, it's a lot of subtle things that add up to be something that's really powerful. And I'm very excited to share it with everyone. And so some things you'll see in this presentation. You'll see our visuals capability. You can see there some trajectories that are plotted around the Earth. You'll see some of that. You'll see information about our API and how that actually works, and how you interact with our code. You'll see some cool tools that are able to generate some really cool output from simulation. This one right here is a tool called LivePlot. You'll see our documentation and some of the really cool tools we've built, not just to document the code itself, but also to generate automated reports where, you go run a script, you want some form of analysis, and it's just right there automatically for you, as opposed to having to go off and create a PowerPoint or a document of some sort. I'll talk about the value add of this approach and how it differs from the way that software projects are typically done. And we'll also talk about what the real savings and impact can be as a result of that. And so all that being said, we'll go ahead and jump right into it. And so there's this kind of common misconception among, us engineers, and it's kind of one that we do to fool ourselves into doing some things right, where we think software is easy, and we think there's this linear progression, and you kind of follow the systems engineering B here, right, where you start with some sort of mission that you're trying to do. You work that with your stakeholder, you define your requirements, architect your system, then you just go write some code, right? And you get to the end, you test your code, your mission's good to fly, and you're good to go. And of course, this is a setup, and that's not how that works. And the reason why that's not how that works is a lot of things, and it's really layered. But the reality is that missions are complicated. Space is really hard, right? If it wasn't, there'd be a lot more organizations doing it. It's a really hard thing to do, to go fly a space mission. And there's a lot of novel stuff that's kind of combining in one place. And when that interacts, there's a lot of stuff that can happen that you weren't really anticipating, right? And so software is the catch-all for that. And it is the thing that has to absorb, hey, our whatever is not performing to spec. Our thrusters don't work right. The IMU, we can't read it. All that good stuff. Our comm budget's not turning out like we thought it would be. Our power isn't sufficient. How do you handle that? Well, a lot of times software has to catch that because it's the most flexible, and it's the thing that happens at the end. And a lot of space organizations tend to struggle with software, especially if you project this sort of linear progression. There's a kind of an axiom in software that take how long you think it'll take and multiply it by 10, and that's how long it'll actually take. And that really has been the experience for how it goes. But the question we asked with ModelSpace is, what if you can take that and turn it on its head? And you could turn software from a disadvantage into an advantage, because as the catch-all for everything, it is the ultimate digital thread that ties the mission together. It is the one place where you can tie in every component of your performance and make sure that the mission is actually going to work well together. And that's the direction that we're heading with ModelSpace. And that's the direction that, frankly, I believe the future is heading, is, everything tied together into a digital thread. Model-based systems engineering, digital twins, those are going to become the norm. Systems engineering run through software. And ModelSpace is a tool, or in my opinion, the best tool to be able to do that. And so before we can jump into how we do that, let's talk about how a space mission really goes. I mentioned that there's kind of this linear progression that we anticipate, where it's like, okay, yeah, we're just gonna, we're gonna start here at the beginning, and we're just gonna go through to the finish. And so this plot kind of illustrates a sample software mission where you can see that the progression is not linear, right? You start out, you're like, we've got the best idea, we're gonna go fly, it's gonna be great, we're gonna revolutionize space. What could be better? And you kind of build that idea until you get to like the PDR phase, and then you get your first design feedback, you do your first review, and they're like, well, this isn't really feasible, or we tried this before, or whatever. And typically there's a setback, and you go, okay, oh no, we have to redesign. But then you redesign, you get through your your PDR or CDR or whatever it is, and you really feel like you're progressing, and you kind of progress through your review where you're like, okay, we're ready to go write some code, right? We're gonna go get it. We've got a qual date. We're gonna get our software in time for that date. And then software is hard, right? It takes longer than you think because you reach this point where you're developing your software. You're like, okay, wow, this is going great. And then you're like, wait a minute, we have to test our software. We have to have a database for our software. We have to have documentation for our software. A lot of that stuff takes a lot of time. Where the overhead associated with writing really good code is a lot more than the actual action of writing code itself. And we're, as humans, not great at anticipating that, right? We don't want that to be the case. And so you reach this point where you're like almost at where qual should be, and it's like, oh no, okay, we got to surge, we got to hit it. And so you hit the ground, and maybe you make some progress for a while, but fundamentally, we talked about software as the catch-all. It's where everything that goes wrong in the mission is caught. It is the realization of Murphy's law in a lot of ways. And so you hit a design issue, and you go, oh man, we've got to fix that. And so then you have to iterate until that design issue is closed. And in a lot of ways, how fast you can iterate is kind of the decider of how fast your software is, more than efficiency. How quickly can I take a change and turn it around? And a lot of times in the current state of the art, we've got a flight software framework and a simulation framework and maybe some sort of analysis framework. And, we've got a database. And so if there's some change, our thruster doesn't work, our IMU doesn't work, we're not getting the GPS signals through that we thought we would in our orbit, those sorts of things. You're having to make those changes in multiple places. Maybe your IMU doesn't work the way you thought it would, and you're having to make a change in GNC and your modeling and sim and your flight software and so on down the line. And so as you get to the end, software is fundamentally iterative. It is hard, and the solution you end up with is never the solution that you thought you were going to start with. But inevitably we get there, right? We get to qual. Maybe some scope was cut along the way, or maybe our mission didn't quite work out the way we thought it would, but we're like, okay, it's good enough. Let's fly. But then there are challenges in operations too, right? Vehicles don't just magically fly and either they work or they don't work, right? There's a lot of gray area in between where it's like, do we have all of our operational uptime? Do we have everything going on? And so it's really easy to miss something and have a vehicle that doesn't work the way that you expected. And so that's kind of, as much as I hate to say it, that's the state of the art. This is the way it goes on software missions. But it doesn't have to be that way. And that's where we're heading with ModelSpace. And that's really fundamentally the problem that ModelSpace was designed to solve. I worked a few places and basically built the tool here that I wish I'd had to solve those problems based on what I'd seen. So let's talk about tools. Early on in a mission, a lot of times you'll use an STK or some form of free flyer orbital analysis tool. A lot of times it's a COTS product to do your early design and analysis, comm budget, power budget, orbit, trade studies, all those sorts of things. Then you proceed into, we're going to mature our concept, right? We want to look a little bit deeper into some of these things, and we want to start looking at some GNC and what's going to work. And a lot of times you'll go to something like a MATLAB for that. And that's great. MATLAB is a great tool for iteration, but unfortunately it's not the best for making really embedded, safe flight software. So then you introduce a third tool where it's like, hey, our mission's more mature. Now we need to start developing flight software. We need to start developing, the actual embedded code that's going to go on the spacecraft. And maybe you start from a tool, or maybe you do that from scratch. But there are limitations to that as well, right? And of course, it's something different entirely than the first two tools that you used. And as you progress, now you identify, hey, we have to have a test pipeline. We have to have a command and telemetry database. We have to have hardware test tools. We have to have, sims that we can actually qualify the software with, that we can run a Monte Carlo with. We have to generate documents. All of those are, or can be, depending on how your organization structures things, a different tool. And then finally, we do have to operate the spacecraft, right? It doesn't just go fly itself. So you need a in control or a free flyer Meridian type tool to be able to go off and actually operate your spacecraft as well. And that's kind of the way that it's done, right? It's multiple tools. If you've worked in organizations, you've probably seen the multiple tools. And that's, again, that's kind of the state of the art, but there's a problem introduced by that. And a few of the problems are, number one, there's no real digital thread that ties the mission together. So for example, we've worked with partners who had a radio that was communicating with a satellite constellation. They did a comm budget, everything looked fine. They had their GNC and everything worked fine. But what didn't happen was that the GNC sim that was kind of the catch, that was analyzing the orbit and how they could perform and point and things, was tied to the comm budget. And so they launched, and it turned out because of Doppler shifts, they actually weren't able to communicate with their space constellation, and the spacecraft was lost. And that's tragic, right? You put a ton of effort into a spacecraft project, and now it's lost. And that's the sort of thing that a really robust digital thread that ties the whole mission together could catch. It could catch those cross-cutting design considerations. And that's exactly what we're trying to do with ModelSpace. ModelSpace is a tool that is a bunch of tools in one. At its heart, it is a really robust qualification sim that can be used for software in the loop. It can be used for hardware in the loop. It can be used for Monte Carlo. It can be used to scale your software design from an initial flight software cut to the actual, hey, this is done. We're ready to finish. And the way that we do that is we made it really simple to use. It can be used for that qualification, but also it can be used for early design and analysis. It can be in like 10 lines of code or less. You can build a sim that's just a simple orbit propagation. If you want to look at, how, comm budgets or power budgets or whatever come together. And when you do that, you give yourself a digital thread where early on, we're able to build those budgets, but then we're able to use them from the same sim that's analyzing our GNC and developing our flight software. And so ModelSpace is the digital thread tool that ties everything together from early stage conceptual design through we're going to mature our concept and iterate rapidly, through flight software development. It can happen in the framework, through a test pipeline that comes with it, through a database that's built out of it, through the actual qualification of Monte Carlo sim. And then we've got a really robust automated documentation tool that can produce some really fantastic reports as well. And so it really is the digital thread that ties a whole mission together that prevents duplicated work, right? Something went wrong with the thruster, and now we have to go update it in the GNC and the flight software and the sim. Here, you just have to do that once. And so you're saving yourself, in that case, triple work, right? But even more than that, you're saving yourself a lot of work associated with having to tie a mission together, right? Did we consider this? Did we consider this? Those cross-cutting design considerations. ModelSpace takes care of those. And that's really the power of the tool that goes beyond anything that you're going to see anywhere else. And that is the 10x capability that comes out of this tool. That is the thing that really changes the way that organizations work. You work less because you're not duplicating work, but really your whole mission is tied together. And that's a really powerful thing that can really change outcomes and save spacecraft missions in many cases. So let's talk about why specifically ModelSpace. It's going to work across the design lifecycle. We talked about that. It also implements the latest technology. At its core, it's in C++, so it's very fast, but it's also wrapped into Python. And the top level interface is in Python, so that you don't need to know that under the hood is in C++. If you just want to do a rapid iteration sim, it is designed for rapid iteration. It's designed to work in that way. But it's also, because it's in Python, you can integrate all kinds of open source packages. You can integrate whatever you want into the sim. And that's a huge advantage versus, hey, this is our proprietary tool. It's our proprietary language. Really, it's Python. And everything is built around that. And that makes it really easy to use. But the big thing is, because it lives with you for your whole mission, it helps you to identify errors earlier. So if you're using a sim that is maybe an SDK or an early phase sim, and then you go, hey, we need to switch to a qual sim that can do Monte Carlos and software in the loop a lot easier, then really where you're switching your simulations, you have an analysis gap where, hey, we can't really do any analysis. We can't really identify anything right now, or maybe we're using limited tools to do so. Because of the rapid iteration capability of ModelSpace, and because it lives for your whole mission, it is a design tool that can inform you early on, through the mid stage where you're really designing your mission. You're doing analysis on component trade studies, and you're catching design errors and issues earlier in the design process than you could elsewhere. There's actually an exponential cost associated with any sort of flaws that are caught in a design as the mission progresses. And so ModelSpace, in helping to identify errors earlier, saves a lot of cost. And then the last thing we'll talk about at the end, but ATTX, we're really mission partners. We're here to help. It's not just a sim that we're throwing over the fence. We're here to help your team. Okay, what is ModelSpace? We talked about this a little bit, but it's really designed for power users. And what we mean by that is it's designed to where you can script things in Python. You don't have to be a Python expert. It's very accessible. And we have tutorials to guide you through everything. But it is designed to be scriptable and scalable. To if you want to do something very complex, you can do that without having the complexity there right from the start. As I mentioned, you can integrate open source packages. It's Monte Carlo capability, and it's operating system agnostic. And that's a big thing too. Using ModelSpace and integrating with one of our many options, which are Docker running natively, and virtual machines, but especially the way we've built it into Docker, into the Visual Studio Code framework. It's entirely operating system agnostic. So whatever your organization uses, it will work for that. And then one of my favorite features is the automated documentation. This is a massive time saver because you're not having to go in and manually document everything that's going on. You can document your code, but more importantly, your analysis products and your test results automatically right there in the framework. And it's really powerful and a massive time saver. We also have a very robust simulation suite. In ModelSpace, you can design, optimize spacecraft trajectories. You can develop complex GNC algorithms. You can do simple analyses of, what do we look like here astrodynamically? Of course, Monte Carlos allow you to iterate rapidly, but you can iterate rapidly early in the mission because you have that Monte Carlo capability right from the start. And then the last thing is, of course, you're able to develop high reliability real-time software. So your embedded software, you can test in simulation before you deploy it, before you go fly it, and really, know that your mission is going to work well before you fly it. And that's the whole point, right? Ultimately, what does ModelSpace do? It saves money, it saves time, and it saves risk, right? You're not having to develop things from scratch. You're catching design issues earlier. A lot of those mission risks that are the things that get you go away, right? The stuff that you anticipate getting you never gets you. It's always the things that you didn't see coming. And ModelSpace, while it can't make everything go away, it makes a lot of that go away. We enable extensive code reuse. No need to use multiple tools. No need to duplicate work. We support really fast iteration capability. We have a built-in model library that comes with a ton of components, a ton of models ready to go right out of the box that you can use. And then the last thing is we're very affordable. Our license costs less than you'd get with just a single seat of most commercial tools. And that's really powerful too, because the license itself is not just for the software. It's for our team to be there with you every step of the way as your mission partners helping to build out your mission. And that's really the point. I left my old job to start this company, not really to make money, more than anything because I wanted to help. I saw the challenges that come with building software in a new organization from the ground up, or even in an existing organization, the challenges that software can pose. We really are here to help. And this isn't we'll throw the software over the fence. Good luck, hope for the best. ATTX is here to help. And if you're watching this video, hopefully you are already one of our partners. And if you're seeing this, then, I hope you're knowing that you can reach out to us because we're going to help your project to succeed. Or if not, then I hope you consider using us because we're not just a sim. We are a mission partner that can come in and help your software to go from being maybe a liability into an asset. That's really what we're here for. Extensive support, documentation. We've got these videos, but also we've got ourselves, and we will go above and beyond for your mission. So that's kind of the intro to why use ModelSpace, and hopefully your organization either is using it or will be using it soon, and you can move on to the next videos and see exactly how to go about using ModelSpace. Thanks, everyone.